Okay, so welcome again, guys, to G Squared Academy, where excellence is epitomized. What I'll be doing here is I'll be trying to answer for you guys some of the most difficult CSEC questions that are out there currently for chemistry. So in this question, it says calculate the mass of iron produced if 0.12 dm cubes of carbon dioxide is produced at room temperature and pressure when iron oxide is reduced by carbon monoxide in the blast furnace. Here they have given us the equation for the reaction down here, so you can see that the equation is balanced, etc. And what we can see is that iron is being produced and iron 3 oxide is being reduced by carbon monoxide over here. Now, the information that we're given is the amount of carbon dioxide produced at RTP. Now, what we should recall is that 1 mole of any substance is equal to 24 liters, or dm cubes. Dm cubes and liters is the same thing at RTP. So X moles would be equal to 0.12, right? And so when we are to find this out, now we're going to have to cross multiply here. So 1 mole times 0.12 is equal to 24 liters times X, yes, and then we're going to solve for X. So this is what we've done down here. So X is equal to 0.12 dm cubes times 1 mole divided by 24 dm cubes. And that works out to be about 0.05 moles. So this is the moles of carbon dioxide that was produced in the reaction, yeah? So that's the moles of carbon dioxide produced. Now the question is, if 0.05 moles of carbon dioxide was produced, how many moles of iron would be produced as well? So what we're going to have to do then is we're going to have to look at the ratio of carbon dioxide to iron. And from the equation, we see that 2 moles of iron is produced when 3 moles of carbon dioxide is produced. So that's a ratio of 2 to 3. Now we know that 0.05 moles of carbon dioxide was produced. So if that number of moles of carbon dioxide was produced, how many moles comparatively would be produced iron? Since the ratio is 2 to 3, then X would be produced when 0.05 moles is produced. And again, we cross multiply. This is what this thing is saying, we cross multiply, so that's going to be 3 times X is equal to 2 times 0.005, and so then we solve for X. X is equal to 2 times 0.005 divided by 3, and that works out to be X is equal to 0.00333 moles of iron. So now we know the moles of iron that is produced. However, the question is not asking us about moles. The question is actually asking about the mass of iron. See it right there, the mass of iron. So calculate the mass of iron produced. So now that we have the moles of iron, we can find the mass. Mass of iron is equal to moles times molar mass. We know the moles because we just calculated that. And so now the molar mass of iron can be found in the periodic table, and we're going to round that up to about 56. So therefore, the number of moles, 0.00333 moles, times the molar mass, which is 56 grams per mole, and that works out to be about 0.187 grams. So from this, what we can see is that when 0.12 dm cubes of CO2 is produced in the blast furnace, at RTP, then 0.187 grams of iron is also produced. I hope you guys find this helpful, and please comment below the video what other question you'd want me to answer next, and I will do that video as you prepare for your examinations. So this is G Squared Academy, where excellence is epitomized. I'll see you guys next time.